Who calls the tools? Application is just going to send to LLM that listen, these tools are available. LLM plus some tool is agent. There was a need for standardization. Anthropic came up with MCP. Now we need to understand the general architecture of MCP, MCP host, MCP client and MCP server. A powerful data collection platform, multiple MCP servers. We are going to be running the Bright data server also in our local only. They have also given the references. End-to-end stock recommendation system. I am going to have multiple agents and these agents will be coordinated by a supervisor. Multi-agent architecture. MCP is trending right now. Everyone is talking about it. MCP. There's some serious hype. But just like any other topic in software engineering, you should be thinking about why did we need MCP? What problem is it solving? How did it come into picture? And just like any other video, that is how we are going to structure this video as well. To understand MCP and the need for it, you need to understand something called tools. So we'll get started with understanding why did tools come into picture, then the problems with tools, and then how MCP is solving that problem. So the understanding of MCP will be like crystal clear. And after that, we are going to write code and we are going to build a project. And I'm going to show you one of the coolest MCP servers out there. It is one of my favorites. So there's a lot of interesting stuff. I highly recommend you to watch the entire video so that you don't miss the code part, because that is like the best part, right? Building project after understanding the entire thing. So I would really recommend to watch the entire video. And there's going to be no promotion after this. Okay, so just one last request, that if you guys genuinely believe that this video needs to reach more people, or this channel in general needs to reach more people, then please help me out. You guys keep commenting that this channel is going to reach 1 million subscribers, but the growth is, to be honest, pretty slow. So if you could please help me out with it, let's aim for like 100 comments. Please do share it with your friends. It would really mean the world to me. Now, without wasting any time, let's get started. Please do subscribe. When LLMs came into picture, like GPT, Gemini, DeepSeek, all of these LLMs started being available to general public, then a lot of frameworks came to build LLM-based apps, right? To build applications that use these LLMs, because now it is available, correct? So there are a lot of frameworks that came. The most popular one is LangChain LangGraph. Tutorials are available for that as well. But now when we build LLM-based apps, there are two very important problems over here. Just listen to them one by one. The first problem, I think you will be able to guess, is that every LLM is trained on a particular date. So it has information up to a particular date. Like for example, if I'm using say GPT and it has information till say October 2023, then it doesn't have the access to the latest information, latest news. So if I'm building an application, then I want the latest information as well. Now I know that there are a lot of solutions for this. We have discussed those as well on the channel, but let's just park this. Okay, so this is one problem that we have in hand. The other problem is that, see, LLMs are good at what? They are just good at answering questions. They're good at NLP, like talking in a simple human language, right? But they don't really perform any task. All that LLM is doing is just guessing that what should be the next word in a particular sentence. It does not perform any task. Now, when so many people are building these applications, LLM-based applications, they want to also perform some task. Like for example, if a user is requesting to schedule a meeting in Google Calendar, or say push a particular code to GitHub, we want our applications to be able to do all of these things. But LLMs can't do this. All that they are doing is just generating some particular text, right? So our applications should be able to perform some task along with, getting the responses from LLM and then using this task to help our user to fulfill the task that our user wants, right? So how do we do that? That is how tools came into picture. I know there might be some confusion right now. I will explain it how tools work also. But let me just clarify a bit more. See, tools can be any tool. Like for example, we have a web search tool. That solves our first problem, which is web search tool is going to do what? It is going to search the web. It is going to scrape the latest sites that are there. And that is one of the coolest servers that I'm going to show you today. That is Bright Data Server. That is really good at going through these sites, scraping the information. We are going to look at that as well. So we're going to write code for that, okay? So there can be many tools. They can be web scraping tool. They can be a tool to just schedule the meeting. So Google Calendar tool. They can be a tool to say push your code to GitHub. So GitHub tool, right? Or get weather tool or calculator tool. So they can be many tools like this. So now before we move ahead, let me explain it to you a bit more about how tools work. Suppose we are building an application and we are using the framework, say LangChain or LangGraph. Let me just quickly write that. And our user is going to be using our application. This is obviously LLM based application, so we have LLMs. It can be any LLM. We could be using GPT, we could be using Gemini, we could be using DeepSeek, literally anything, okay? Now, in our application, what we are going to do is we are going to configure some tools. We are going to say that, okay, we can use these particular tools. So we are going to have a list of tools that are available. Like for example, it can be a GitHub tool. It can be a Google Calendar tool, it can be a Google Docs tool, it can be a Google Sheet tool, it can be literally any tool, it can be Slack tool, Discord tool, anything, okay? It can be a database tool that is good at, say, SQL queries or anything like that, right? So any tools can be there. Now, suppose there is Sprite Data tool, because this is the one that we are going to be writing code for. This is for web search, extracting any latest information and things like that. Now, what is going to happen is our user is going to send a query. Suppose the query is, give me the latest relationship situation between India and Pakistan. Now, this is a pretty recent information that our LLM might not have, right? Mostly it is not going to have. So, how will our application know that which tool to call? Obviously, our application is not going to know. Our LLM can understand though, because it is good at understanding simple language, right? Natural language. So, our LLM is smart enough to understand that if I have these tools available, then for this particular query, what tool can I call? So what our application is going to do is, from our application, we are going to send the user query as well as the available list of tools, right? So these tools are available. Our application is going to tell our LLM. Now corresponding to every tool, no, there is one string that is there that tells in simple English, that like simple natural language, that this is the task that this tool performs. Like for example, this searches or extracts out the information from various sites. This is going to help us schedule meetings or things like that, right? So our LLM is going to understand from this string, because LLM can do that. LLM is good at understanding natural language. So looking at these strings, our LLM is going to understand that for this particular query, I will need this particular tool. Like for the latest information, the latest news, suppose I want to use Sprite Data ka tool. So our LLM is going to respond back saying, listen, you need to use this particular tool, or you need to use these particular tools. And our LangChain is the one that will be responsible, LangChain or LangGraph. Our framework is going to be the one that is going to call this particular tool. So this tool is going to be executed, and then again we are going to send whatever is the response to LLM, and then LLM is going to send a good response that we can send to our user. So who calls the tools? Our application, our LangChain framework is responsible for calling the tools. But how does application come to know that which tools to use? Because it can't understand. LLM can understand. So LLM tells that out of these available tools, call this tool. And our LangChain is going to call that particular tool. It is going to execute it. And then it is going to tell LLM, see, this is how I executed this tool, and this is the information available with me. Like for example, for the India-Pakistan relationship, suppose Bright Data extracts info from some news channels or something like that, and then it is going to send that to LLM. Now again, now it has the context. It has information available that, okay, this is the new news available, and LLM is great at answering questions, so it is going to answer the question. That is going to be returned to our user. Let me tell you the flow just once more so that it is completely clear. User is going to send a query, and it can be anything. Suppose, now let's take another example, schedule a meeting for me at this particular time for this particular title or something like that, okay? So our application is just going to send to LLM that, listen, these tools are available and this is the query. So it is going to see that, oh, this is something that can be done by Google Calendar. So it is going to reply back to our application and say, call this particular tool, and it is going to execute the tool. And this is where the scheduling of the meeting will actually happen, because LLM can't perform tasks. LLM is just good at answering the questions. So this is where our task is going to be performed. This is where our meeting is going to be scheduled, or this is where our code is going to be pushed if that is what user wants. And after that is done, our application is again going to tell LLM that, okay, this is the response that I got from the tool, and accordingly LLM is going to frame like a good answer for the user that, okay, your meeting has been scheduled, or your code has been pushed, or this is the latest situation between India and Pakistan. So that is how things work. I hope this entire flow is now completely clear. So I have opened the LangChain documentation for tools right now, And in the first line itself, let's check it out. Inputs are designed to be generated by models and their outputs are designed to be passed back to the model. So I now hope that from the diagram this part is completely clear, because what to send to the tool is also told by the LLM, and then the output from the tool is also again passed back to the LLM so that a natural language response can be generated, so that that response can be sent to the user. Okay. Now you can see there are so many tools that are already available for us, like search-based tools, code interpreter tools, productivity tools, web browsing tools, database tools, finance tools, and there's a huge list of tools that are available, right? So you can check it out over here. We are going to be using these bright data tools today, but there are so many tools and I highly recommend that you should try different tools out. Like for example, there is Google Drive, there is Google Finance, Google Lens, Google Search, there is GraphQL, there is Discord, there is JSON toolkit. There's a lot of tools available, right? Also, you can create your own custom tools also. This is something that we are not doing in this video, and it is actually fairly simple to do. And if you would like me to do a separate video on that, let me know in the comments. Do let me know. But just to give you a simple context, like how would you do that? See, in tools, you need to have a string telling that this tool does this particular task, right? So your LLM will understand that, okay, this tool is doing this particular task and when to use the tool. Other than that, you just need to add some business logic. Like, let's take a very simple example. Suppose you are creating your own calculator tool, okay? So instead of multiplication in your application, you want it whenever a user is telling you to multiply, you actually want to divide. All you have to do is just in the string, you're going to say multiply two numbers, but what business logic you're going to do is you're actually going to do the division. So your LLM is going to understand from that string that, okay, this is the tool that I have to call, and the logic, it is just going to call that the output is going to be sent to the LLM and it is going to generate the response and pass it to the user. So if you want me to create a separate video generating like creating different custom tools, let me know. But I hope this gives you a good idea about tools. And now it's finally time to get started and discuss what is the problem with these tools and why did MCP come into picture. You guys must have heard the term agent a lot these days, right? What is the agent? A very simple definition of agent is LLM plus some tool is agent. It is as simple as that. Because LLMs plus you should be able to perform some task which we do in tool, some action, some business logic, anything, any task that you're performing in your tool plus LLM becomes your agent. It is as simple as that. Now you know that agents have become very famous these days, right? Like everyone is talking about agents, everyone is trying to build LLM based apps. So as these things became more and more famous, we saw a shift happening in the industry. Earlier, companies used to expose their APIs which developers can come and develop applications on. But now developers are building what? They are building LLM based apps. So companies have started exposing their tools. Exactly. So like this, GitHub exposed their own tools, Google exposed their own tools for Drive, for Sheets and so on, Slack exposed their own tools, Discord exposed their own tools. So now when so many companies are making their own tools, what do we need over here? Standardization. Let me explain a bit more. See, when we have REST API calls, what happens? Like when we send a request from say front end to back end, we know that exactly this is how our API should look like. This is how the request is going to look like. This is how the response is going to look like. There's going to be headers. There's going to be body. It can be of the type get, put, post. There's going to be status code. So there is a standardization across. So that is used, because of which we are able to test our APIs using Postman. We have documentation using Swagger and all of that, right? So there is standardization that is followed across the industry. Now that agents have become so famous, now that all the companies have started exposing their tools, there was a need for standardization in this area. And that is why Anthropic came up with MCP. MCP is nothing but it is standardization to make sure all the companies are exposing their tools in a particular format by following some particular protocol so that there is a standardization in exposing the tools. This is the official documentation of Model Context Protocol. Firstly, let's understand why do we call it Model Context Protocol. first part should be clearer. It is protocol. It is like, rules that we are supposed to follow for the standardization. What does it standardize? How applications provide context to LLM. So when we are, say, giving the latest news or latest information to LLM, what are we providing? We are providing some context. And to whom are we providing? To our models, to our LLMs. So protocol to provide context to our models. So now I hope it is completely clear. Again, repeating that, protocol basically a set of rules, standardization to provide context, like relative new information or after performing some task, this is the context to our model, to our LLM, right? So provide protocol to provide context to our model is MCP. You must have seen this definition lot. Everyone says this whenever anyone is explaining MCP. It is like USB-C port for AI applications because it is given in the documentation. It's like if you want to connect like different ports, like for like suppose your laptop, your phone. So there's one standard way, right? USB-C port is becoming the standard way of connecting all the different devices. So this is the analogy that everyone gives, but I personally usually, like when I heard it for the first time, I was like, what analogy is this? I'm not understanding why do we need MCP from this analogy. I feel understanding from the tools part is easier. Let me know, do you find this more helpful, or do you find understanding that, okay, why tools, and then now you are understanding that, okay, now there are different tools, so you need the standardization for that, and that is why MCP. Which analogy or which explanation is better? Let me know, because everywhere I see everyone explaining MCP, this is what they went for. But okay, cool. Anyway, now we need to understand the general architecture of MCP. How does it actually work? So this is also client-server architecture like REST API itself. So the different servers that are being exposed by different companies like GitHub or Bright Data or Google or Slack or Discord, anything, right? So they are going to run on a different server or the same server as a different process. So the process is going to be different. You could run it on the same computer or you could run it on a different computer. The process should be different, right? And you're going to call it from like a client. So it is basically you're going to call your server from your client, and where is the client? It is on your host. So there are three terms that you should know about: MCP host, MCP client, and MCP server. Let me clarify it once more. See, MCP server is what? These small servers that companies have written, right? So how they are exposing their tools. So we have to run those that business logic that has been given by these different companies somewhere, right? So we have to run their server somewhere. So the process where we are running the logic that has been provided by different servers, that is like this MCP server. And our application, right, that is MCP client, it is running in our host. So host is like, think of it like your computer where you're running your application, and then you're using server. Your server could again be on your computer, or it could be somewhere else. Now there has to be a 1:1 connection between the client and the server. So you can see that there has to be 1:1 connection. For that, one thing that you should know about is transport. So how the communication happens between client and server is something that you should know about. So if it is on the same system, okay, same computer, then you can use the transport STDIO, okay, standard input output. So this is used when building command line tools, implementing local integrations. So whenever you are building locally, like your both client and server are present in your computer, then STDIO is good enough. Or if your server is going to be running somewhere else, you can use server sent events, or you could be using HTTP, right? So there are basically three transport modes over here. You can check them out. Everything is available in the documentation. If you have learned a bit about high-level system design, then you would know about SSE and HTTP. If not, it is okay. Don't worry about it too much, but I would recommend you to study all of this. By the way, their documentation is pretty decent. You can see different SDKs in different languages like Python, TypeScript, Java, Kotlin, and so on. Then you will see they have also given some example servers and example clients. So you can see how to configure it. Now I know we are going to write code after this, so just telling you that all of the documentation is present. You can actually go through it. There are example clients available. There are tutorials available how to debug building MCP with LLMs. But it is time that we get to the code now. For the code part, let's take a very common use case. Suppose I want to check flights from place A to place B on a particular date. Now this information is very public and it is easily available on a lot of sites. But our LLMs do not have this information. LLMs are dated. They are trained using data up to a particular date only. So in order to find the information that is very recent, like for example, if I search who won IPL 2025. This is a pretty recent information. Our LLMs will not have it. Our LLM is going to need a tool in order to web search. So similarly, if I have to find flights from place A to place B, here we need a very powerful data collection tool that can scrape the sites and get this information for us. Let's take one more example. Suppose I want to ask our LLM, tell me the stocks that I should invest in and the current market prices of that stock. Obviously, our LLM doesn't have this information. We need a very good tool over here that can get this information from the sites that are available, that can check out the current market prices of the stocks. So for this, we are going to be using Bright Data, which is a very common platform. As you can see, it is trusted by 20,000 plus customers worldwide. So if I just go to the documentation here, you can see that it provides a powerful data collection platform to help you reliably build, run and scale web scraping operations. So in order to check flights information, stock market price and all of this, we can easily scrape the information and access it, right? So discover, access, navigate, extract and structure the web, delivering unmatched performance at every step, right? So they have web access APIs, proxy infra, data feeds. We are going to be using their MCP server. So we are going to go through the configuration over here, and this is what we are going to be using in our code. And in order to do some setup, you can just log in. I'm going to log in with Google. And once you do that, you can check out their data sets as well. So they have a lot of data sets available and web scrapers as well. So they have web scrapers for LinkedIn, Insta, TikTok. Pretty cool, right? So you can just go to your account settings and create an API key. So I've already done this. I have an API key and I have already set this up in my environment variables. So we can start writing the code part now. We know that we use LangChain LangGraph to build LLM based apps. What about using MCP? How can we do that? So here you can see LangChain MCP Adapters is a package that makes it easy to use MCP with LangChain LangGraph, and this is what we'll be using. So let's go to their GitHub, and there's really good documentation available over here which we are going to refer. So we will have MCP servers, clients as we just discussed, and this is the code that we are going to be using to create our client and server. So you can see that they have given code for writing server as well, right? We will be using Bright Data's MCP server, so we will not have to write the server code. We will just need to configure that we want to use Bright Data MCP server, and we'll write the client part. But instead of using one server, one client code, we'll be using the code where we can have multiple MCP servers, because it is very easy to follow as well. Plus, if you want to use multiple servers, it's a very common use case, so it makes sense to use this, right? So we'll be using this. Again, we'll not be writing the server code, we'll be using the Bright Data MCP server, and we'll be writing the client part. So we'll need to use this multi-server MCP client, right? So we'll need to copy this to our code and we'll be using this. As I said, I have set the environment variables. So this is the OpenAI API key, the Bright Data API token, and the web unlocker zone. So I created a web unlocker in Bright Data itself. This is optional for you. I've also added the requirements. So python.env, this is to load the environment variables, LangChain LangGraph. LangChain MCP Adapters is what we are going to be using, the main package, LangChain OpenAI. And I'll tell you why I have written this. This we are going to use for a more complex example. So let's get started with writing a code. The first thing that I obviously will do is to load our environment variables. So for that, let me just import. So this is the main function that we are going to be calling, and this is what we basically need to write code for. And our main code is going to come over here. For this code, let's go back to our documentation. So I'm just going to copy this. The main part is going to be multi-server MCP client, right? And I'm just going to paste it over here. Let me just correct the indentation. So in the example that they had given, they had taken two servers, the math server and the weather server. So they had configured accordingly. In our case, we are going to be using the Bright Data server, right? So we need to configure that. So we have only one server. We can keep adding servers which will be comma separated over here. And the transport is going to remain stdio because we are going to be running the Bright Data server also in our local only. But what is the configuration that is required for that? So the server example that they had given, the math server example, we had to run it using this command, that Python, and then the arguments were that this is where the server is present, right? Instead of that, so what do we need for Bright Data? let's go to the Educosys documentation in the configuration that they have given. So we will run using the npx command, and this is like we have to give the token, and this is how we can use it. Or we can also check out their GitHub. So let's go to their GitHub, let's go down. They have given really good documentation, so you can check it out. The demos are also available. So you can see the features that are there, right? Web unlocker, browser control, seamless integration, real-time web access. So, and the usage examples are also given. So I'm showing you some examples, right? But other than that, if you want more examples, you can check it out. You can check out, like for examples, Tesla's current market cap, or Wikipedia article of the day, right? Or 7-day weather forecast. So you can check these examples, pretty cool examples. And this is the configuration that they have given. So again, web unlocker is optional, browser zone is optional, rate limit is optional, but we can use this, right? So we just need this part, the command arguments and the environment variables, right? So this is all that we need. We are going to go back to our code and we are going to paste that. We will still need to mention the transport part, by the way, so don't forget that. Now that this is done, let me just correct it 1 second. Okay, I'm going to need a comma over here. Let me just move this and let me add the environment variables over here. Now that the Educosys configuration is done, let's look at the rest of the code. So what we do over here, after creating the client, we are going to get the tools from the client. So if we go back to the documentation, here you can see over here they have mentioned that this code is going to create a new MCP client session for each tool invocation, right? So we are just going to first get the tools. So the session is going to be created accordingly, and we are going to create agent over here. So we are using create React agent. Again, for this code, you can refer to this documentation over here. So if you just go to LangGraph quick start, right? So this is what they suggest to use also, create React agent. So we can mention model, tools and prompt like this. So it is usually better to give a prompt and properly like tools and model like this. So let's do that as well. Instead of just mentioning over here, let me just create the model separately. So I'm going to be using init chat model for that. So let me just quickly import that. And we can use the same model itself, GPT 4.1 sounds fine. And we can mention the API key from our environment variables. And we are going to pass this created model to create React agent. So we are passing the tools. We can also give a prompt over here because this will be very helpful, right? This is going to help our LLM understand how to behave. So this is for further clarity. So now instead of asking for maths and weather response, we are going to obviously ask for something else. So I'm just going to name it as agent response. And let's ask a very simple message to begin with. Suppose let's ask who won IPL 2025. And in the agent response, so we are going to have a lot of messages, right? So we are going to print the last message and we are going to print just the content part of it. And we are ready to run our code. Let's run the code. So I'm just going to go python main.py and let's run it again. Okay, now you can see the zone exists. It is starting the server now. So it is executing this query. The tool ran and we got the response that the winner of the IPL 2025 was RCB. So they defeated Punjab Kings by 6 runs and they've also given the references. Pretty cool, right? So suppose you want to check more, tell me the available flights. Let's do that as well. From say Bangalore to Delhi on December 1, and let's run this. So it started the server. It is executing the query. So the tool ran. And we got the response. You can see that here are some available flight options from Bangalore to Delhi on December 1st, 2025 based on current listing from major travel portals, and you can see their fares as well. So example flights, Air India, Indigo. So you can see where to book from as well. So pretty nice, right? It's time that we level up and build one more very, very interesting project. I'm now going to be building end-to-end stock recommendation system, and here we are not just going to recommend that okay, invest in these stocks. I want to create end-to-end system where my system tells that okay, these are the current really promising 2 stocks. I also want to check the current market prices of these stocks, and I also want to check the news articles that are there related to these stocks and summarize them for me. And depending on the market prices, depending on the news articles, I want our system to tell us that at this target price we can buy or sell our stocks. So the end-to-end recommendation system, right? Now the problem over here is that if I send in one message itself to LLM along with the Bright Data tool that do all of these things. Now even though our Bright Data tool will be able to do all of these tasks, so it can find the current market prices, it can tell you the news, it can summarize all of that, right? So it can scrape the information from internet. But even then, our LLM is going to get confused. Why? Because now there are too many tasks to be performed. So instead of that, what we are going to do in our system is, we are going to create multiple agents with clear set of responsibilities. So one agent is going to just say, tell that okay, these 2 are the really promising stocks. Another agent is going to find the current market prices. Another agent is going to find the news articles, and then we'll be able to summarize. And another agent is finally going to tell that okay, at this target price you can do buy or sell, right? So I'm going to have multiple agents, and these agents will be coordinated by a supervisor. So here what is going to happen is I'm going to have clear set of responsibilities, and obviously our system is going to be more modular. So this is a very interesting project, right? Let's get started. We are going to be using LangGraph Supervisor, which is the Python library that simplifies building hierarchical multi-agent systems with LangGraph. So what are the key features? Single supervisor or the orchestrator that handles all user interactions. I hope it is clear that the supervisor or the orchestrator is also going to be an agent itself. It is just going to be handling the user interactions, and it is going to be delegating the tasks to worker agents. So worker agents will be the agents that will communicate exclusively with the supervisor. It will do like a specific task, and the coordination is going to be done by the supervisor agent. So that is also an agent itself, okay? And also here there is support for multi-hierarchical levels. So basically supervisors or supervisors is also possible. It is very easy to follow, guys. We are going to just follow this tutorial. It is very simple. Let's just go through the documentation, and we are just going to follow it step by step. So supervisor is a multi-agent architecture where specialized agents are coordinated by the supervisor agent. Okay, so supervisor is also an agent only. Supervisor agent controls all communication flow and task delegation, making decisions about which agent to invoke based on the current context and task requirements. So it is going to decide which agent to call, and then it is just going to call it one by one as we want, okay? And what are the different steps that we are going to follow for this project? We are first going to get started with creating the worker agents. So in this example, they have created math agents. We are going to be creating the different agents for our stock recommendation system. And once we have done creating the work agents, so like this we can create. After that, we are going to create the supervisor using this create supervisor. Here we just have to pass the agents. So here they have used 2 agents. We are going to be using 4 agents. And once we have done that, our end-to-end stock recommendation system is going to be ready. So let's get started with writing the code. Let's get started by creating a new file, multi-agent demo. By the way, all the code is present in the link in the description, so you can check that out. I'm just going to get started by copy pasting the code that we have just written. The only difference is that earlier we had 1 agent, right? So now we'll need to create more agents. And here instead of like asking over here itself, let us pass the query in the function. So I'm just going to say give me a good stock recommendation from NSE. And we are going to pass this query to our function. So now instead of 1 agent, I need to create multiple agents, right? So we are going to be creating 4 agents now. So my first agent, I'm just going to call it stock finder agent. Then similarly, we are going to have market data agent, news analyst agent, and we are going to have a price recommender agent. See guys, in applications like these, prompt plays a very, very important role. So the more clear the prompt is, the better our system is going to perform. So I'm going to take some time to write really good prompts so that we get good results, right? So let me just do that. And I am just going to add a name over here. And as you can see, I've just not told to find the stock. I've also told that act like the research analyst, avoid penny stocks. I've also told that how the output should look like, the response should look like what, right? So the more detailed you can make it, the better it is going to be. Similarly, let me give the prompts for the other 3 agents as well. So I'm telling that what all you should include in the analysis that you're giving me, right? So I just don't want the current market price, but I also want, say, the previous closing price and those things, right? So I want all the details. So I'm clearly telling that what all things am I looking for. So all of these tasks our Bright Data tool will be able to do, right? So searching for the articles, getting the market prices. So for all of this, we are using Bright Data. It is just that we have different agents now. I hope this part is clear. So after the Bright Data will give the news, our LLM will classify it as positive, negative or neutral. So in all the agents, I am following the similar format. I am also telling it how it should respond. So to the price recommender agent, we will give the outputs of the first 2, right? So we'll also give the market data and we'll also give the news data. So both of them will be passed to the price recommender agent, and based on that will be recommended finally. Now that we have created the worker agents, let's go back to the documentation. Here, other than the worker agents, so here they were just creating the agents, right? So create React agents. So this is what we just did. There's also this one code that they have written to just pretty print the messages. So if we copy this, this is how our output is going to look like, right? So I'm just going to copy paste this as well. So this is just for pretty output, that's it. So I want the output to look something like this, and that is why I just copy pasted that. So this was the agent code. We already have this. And now we are ready to create our supervisor. So I'm going to copy this. Let's go back to the code. And now we don't need this. We are going to be creating the supervisor. I already have an chat model. Now here, instead of these research agent and math agents, I just need to pass my own agents and give the prompt. And let me just quickly add a prompt also. Here again, I am just telling that you are a supervisor managing, instead of 2, I can say 4 agents. And I just need to tell the agents, right? So this should be good enough. Let's go back to the documentation. So we have done this part. So now we can just stream like this. Instead of the content, we'll just give our query, right? And we'll be able to print the response. So let's come back. We have our supervisor and we had passed the query. So it is starting the server. So stock finder agent ran. So after stock finder agent, it transferred back to supervisor, then transferred to market data agent, then back to supervisor, then news analyst agent, back to supervisor, price recommender agent, back to supervisor, and then it is giving the entire response together. So here are top 2 recommendations from NSE. It is saying Tata Motors and ICICI Bank. So recommendation is to buy on dips. This is the entry target. and it is giving the rationale behind it. Similarly, for ICICI, it is giving the recommendation of buy, the entry target, and the rationale behind it. So this is really cool, right? It used price data to get the news, to get the current market prices, and it did the final analysis, and supervisor made sure that every agent is doing one task, and it coordinated the entire thing. So this brings us to the end of the video. Hope you enjoyed it and understood MCP really well. If you have any doubts, any questions, please do let me know in the comments. I would love to answer them, and I would love to see you all participating in a healthy discussion. Also, try writing the code yourself. It is available in the description. It will give you a lot of confidence once you write it yourself, so you'll be able to ask better questions as well. Also, a lot of effort went behind this video. Hope you can see it. And if you think it was good, if you enjoyed it, if you found it helpful, please consider subscribing. And if you think it deserves to be shared on LinkedIn and Insta, please consider doing it. It would mean a lot to me. See you next time. Bye.